Welcome back, Generals, to another Let's Fix Generals 0 Hour to make the best game ever. Good. So last session we said we want to create one function that works on all of these, right? So how about we say parse parse gsym, stsym, lcsym, or yeah, parse, or we just say parse sim. How about that? Parse sim. Are there any other sims, by the way? Wait, hold on. Parse lcsym sim. There's more. Insectsim. Yeah, we don't care about insectsim, I think. rsim, register sim. Register? What does that mean? Register sim. Register symbol. Okay. Source line. S line. Local sim. psim. Let me put a default here. Which ones are we currently not looking at? Let me do that real quick here. What happened? What? Oh. There's nothing inside, so it doesn't put a breakpoint, I guess. Let's try again. Okay, so we do hit it for for E. Let me put here a continue. Okay, that doesn't hit anything. So it's really just these few guys here. Okay. Okay, then can remove this. Okay, good. Then yeah, we create a function Parse where we just forward the calls to. How about that? So we create this guy here. We move here. We move here. We put that here. MachOCodeGen. And then we move this guy down here, and then let's do assert this one here. Asserts ends with this or this, and then we pass this symbol and function index. We probably also want to say what kind of symbol it is. So we have this one here, local, static, global. Okay, then what we do is function index, variable type, yeah, type, and then with type we pass here type. Then here we pass variable type local. I put a space here. Then here we comment out this garbage. Here. Okay. And so this one was a static, right? Static. And this one is global. And put this assert here. And we comment out this stuff here. Okay. Good, then we can work off of one function. Now, can we actually delete it? I mean, we have this here. Create new, verify existing. I wonder if this is ever called. Let's put a breakpoint here. Let's move this comment down here. I guess we will delete it because it's probably wrong. I guess G just stands for global, S for static, and V for, I don't know. But it's weird because both the local symbol and the static symbol can both have S and V, right? So that's weird. What does that tell us? I don't know. That is weird. Good. So I guess we can delete this guy here because there's nothing interesting. And same with this name, description, section, name, address. Yeah, I think we can just remove that. Good. That looks simple enough. Okay. How about we call it SVG? Yeah, we still need to figure out what that means. I don't know what it is. It's weird. Yeah. Good. Good. Then we have one function, which would be called in. Yeah. Yeah, I think this looks good. Good. Then I guess we are back to research. Okay, so basically we have symbols inside functions, outside functions. We have different types here: stsym, lcsym, and globalsym, and we have different suffixes: g, s, v, where g probably just stands for global, and that's probably it. But s and v, we don't know. S probably static, and v, who knows? And then verify existing. Yeah. Okay, so I wanted to know if this assert hits here or not. If it's not hitting, then we can remove that. Address to variable. I think it doesn't hit. Let's see. Let's see. It does hit. Oh. Okay. Why? What do we have here? Ah, it does hit because I see. Right. NX argv. NX argvg. Oh. Oh. Right. Address 0. That doesn't help much. Yeah. Okay, well, if it's what do we do if the address is 0? Then what? I assume that there are many symbols, G symbols, that have the same name, right? What do we do with these? So let's search for a G symbol. Or are these all unique? G. Define GUID. So if we search for this guy, let's search for NKG. There we go. This is where the trouble starts. Yeah. So there are a lot of places where we have an NKG. Sure. What now? Yeah. So also some are marked as weak symbols and others not. I don't know what this tells us. It's kind of weird. Like, what's the difference between this one and this one? Why is this weak and the other not? Maybe because of the function. Grant stealth behavior. Instant death. Grant stealth. I don't know why this is a weak one and the other not. Let's ask ChatGPT. What does it mean? What does it mean when a debug symbol is? I think there was some end list here, and weak def and desk field indicates the static and dynamic linkers that the symbol definition is weak, allowing a non-weak symbol to also be used. Allowing a non-weak symbol to also be used, which causes the weak definition to be discarded. What? The n weak def bit of the n disk field indicates to the static and dynamic linkers that the symbol definition is weak, allowing a non-weak symbol to also be used, which causes the weak definition to be discarded. Does this have any relevance for us? weak def. Qualist symbol is a weak definition. It's allowed to be missing. Okay, I think I understand this here. To deny that the undefined symbol is allowed to be missing is to have the address of 0 and missing. Right, so it's when you so let's say you link to a library and that has a symbol with a weak reference or weak definition. Static. Static. I don't know what the difference between a static and a dynamic linker is. Well, what is the difference between a static and dynamic linker? Serve different roles. Static linker during compilation linking. Okay. Static libraries, larger. Okay. The dynamic linker is for the runtime. Okay, I see. Okay, that makes sense. Dynamically and runtime. Okay. I see. I see. Okay, then I mean, if it's about linking, then I think we don't really care about this information. I wouldn't know what to do with this. It's something. It's for the compiler, for the linker. Yeah. It seems relevant for us. Yeah. Good. Let's get back. Good. Good, so we are here in, right, so it will have 0 address, right, yeah, 0 address, yeah. Okay, let's ask chat once more. Why does ChatGPT now put so much symbols in here? What's up with that? That's new, isn't it? All these Unicode symbols here. What the hell? So let's say I think I asked it already a couple times, but we never got a perfectly correct answer. What do the prefixes, no, suffixes. The suffixes G, S, and V mean in N, what is it? In GSOM, STSOM, and LCSOM, and LCSOM symbols. GSV that appear alongside that. Symbols provide additional type information about the symbols. These suffixes are primarily used by debugging tools to indicate the storage class. Global, static, automatic, local. Automatic. Global, static, automatic. Global symbol, maybe extern or defined globally. Maybe extern or defined globally. Static symbol, file, local, static storage. Okay. Global, static. Yeah, but this is not true because static variables, file, local, static, yeah, local variable. Okay, let me double check this once more before I ask stupid question. I put a breakpoint here and here. Yeah. Well, let's say I can eyeball it. Yeah. What? Oh. Right. Let's remove this for now. Okay, so watch symbol. So this one is a V. Yeah. Another V. And this is an S. S here, section 16. S section D. S. S. So we have seen S and V here. And here we have seen S. 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 And V. There we go. So certainly both of these have both S and V suffixes. So let's ask Mr. ChatGPT. let's ask. I have seen both S and V suffixes with antisym and elsisym. What does that mean? Or how how does that work? Yeah, I don't know. You're right. Yeah, of course. This happens because these suffixes indicate different storage classes, and sometimes both can apply to the same symbol type. SV, SV. Okay, what is this meaning? Static variable, file local static storage duration. Static local variable inside a function. Oh, inside a function? Is that true? So V is inside a function. Local variable with static storage. Same as what? Local variable with static storage. What? Static file scope variable. Static file scope. I hope ChatGPT is not just guessing, but actually pulled this knowledge from somewhere correctly. Yeah. I mean, it looks promising, but who knows? Key observations. What the key? What is this? What is ChatGPT doing? Oh my gosh. The summary is a dot. Okay, static local variables. Okay, so apparently these two are the same. Static local variables inside functions. But then, okay, strange. And these are distinct. File static, stack variable. Inside a function. I'm so confused. So this V is inside a function. This is also inside a function, and this also inside a function. Is that true? So it claims that these three are inside functions. Okay, let's verify if that is true. So this one, Parse SCSym. So he says they are all inside functions. So basically that should mean that the function index is always set. Let's see. That's not true. This one is not in the function. And the symbol is not in the function. So, okay, so ChatGPT already wrong here. Yeah. But nice try. But maybe V. Okay, hold on. So what is this ending with? S. 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 Local S. Okay, so we know if it's in a function if this index is not invalid. Yeah. S static variable file local. So symbol S display rect display list capture name. Can we get a V, please? One V. There. S cached path. That's a V. Cached path. S cached path. Yeah. So my guess is that V simply means it's not static and S means it's static. That's my guess. Could that be? So V is just a variable. V is variable, S is static. I think that makes the most sense. Yeah, not static. So yeah, and it can be inside a function, but for us, it's likely never in a function because we don't have symbols for non-static variables inside functions. I think, yeah, that would be great if we had that, but I think we don't. It's a shame. If we had more symbols, we could probably build a lot more things. Yeah. 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 Good. Yeah. I think that makes sense. Yeah. Yeah. Okay, but then what's the difference between LC symbol and ST symbol? That's the next big question. Because so far, so this is inside a function. V. V. It's called S-cached pass. Just looking at the name would imply it's static with the S prefix. It is inside a function. Boah. There's another one. Another S. This is. Let's clean up here a little bit. Let's put the function index here as well. Okay, so a function, so it's not in a function. Not in a function. V, that's in a function. Okay. S, not in a function. V is in a function. Okay, so can we maybe say, I'm just like guessing, so assert function index is function index is invalid index, or it ends with V when it's in a function, or function index is not invalid and it ends with S. Now, is that true? Let's see. Let's see. So that would mean that the V and S would tell us if it's in a function or not. Okay, that has passed, and let's put the same here. Okay, okay, looks like we have demystified it then. Let's put that here. Now that is wild. That is wild. Huh. Okay, interesting. Interesting. Okay, so S and V simply doesn't tell us anything that we don't already know. We already know that's in a function. There. Good. Then we say S means it is S means it is in a it is S means it is in S equals not in function. V in function. Okay. Okay. Okay, looks like we have that demystified. Okay, but the function index already tells us this, so we don't care. And here this is always G, so we don't care as well. That means we don't care about any of this, right? Yeah. Good, let's remove this garbage. Okay, then the next step, let's try to figure out what the exact difference between stsim and LC sim is? What is the difference? Both can be inside a function and outside the function. So what's the difference between these guys? Okay, so symbol. So this one is in function as cache digmap in function static stsim static. Okay, but so my current assumption is that stsim means it is a static symbol, and this means it's not a static symbol. But seconds per logic frames real. Didn't we see the same symbol in here? How does that work? As results. Look, logic frames per seconds real is in both stsim and in lcsim. What am I supposed to do with that? Okay, section is 7. Description 3b. Let's see if it shows up on the other one again. Seconds per logic frame real. It is in a different section, right? Man, I should have... Oh, hold on. Let's create a copy of this thing. Notepad. Okay. Let's put a breakpoint here. So we're looking for seconds per logic frame. Oh, logic frames per second. It's different. It's different. Look at that. They read very similar. Okay, so one is logic frames per seconds, and the other is seconds per logic frame. Section 7, section 16. Okay. 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 Logic frames per seconds. Okay, but then what is the difference between these guys? lcsim, stsim, static, lc, not static. I'm not sure what the difference in C++ is, but there must be a difference. Let's look at this here once more, what he said here. So he said that this is static variables and these are local variable with static storage. Static symbol, file local, static storage, local common symbol, automatic allocated on the stack. No, it's not. Let me ask you once more. I think the answers. Let's search online. How about that? Let's not ask the ChatGPT. Let's search for these two guys. Actually, hold on. We probably also have some documentation here, right? Let me see. BSS segment variable with internal linkage. Data segment variable with internal linkage. BSS. It wasn't the BSS one BSS one that is uninitialized, and ST is with initialization value. Isn't that the difference then? That could be, maybe. So section 16 is the ordinal. So we're looking at, hold on, hexadecimal 22, 21, this one, and there's also 22. What's the difference here? There's also a description and the value raises. Look at that. What does that mean? Is that like an index of this symbol? 91, 59. Man, what is this bullshit? 60. $59, 22, 7. Okay, let me, hold on. There was 7 here, 7 and 22 down here. 22, 7, 7, 7, 22. But here we also have 22. So, okay, let's see what that is. So we're looking at 6 and index 6 and let's use the ordinal, because the ordinal is also in here. So 7, can we see it? 1, 5, literal. I like this. Literal 4. It tells us it's 4 bytes, I guess. This one is 8 bytes. This one is a C string. Yeah. Wasn't there something for float as well? What is CF string? I don't know. Literal 8. Literal 8. Shouldn't there then also be a literal 1, literal 2? But maybe they are just packed in here. Maybe. Yeah. Okay, what is 22? Can we see it? Maybe? Hello? Why is it not showing me values anymore when hovering? Okay, that's some... Huh? So it's showing me for here, and here, but not here. Why? Why? Oh man, these softwares, it's always bugged. Okay, let's end the session. I think then we can see it. There we go. So 22 is BSS. Yeah, okay, so BSS means it's uninitialized, right? Yeah, okay. Okay, but this is not, I like this because that means from here we can pull a value from here as well. I just don't know what to do with booleans and 2 bytes. But maybe they also refer to this. But then that would be quite a waste, wouldn't it be? I mean, if every value would be padded to 4 bytes, it would be a waste. But maybe they say, okay, maybe they... I would expect that they tightly pack everything together, right? But then I wonder, why is there no literal 1 and literal 2? I don't know. Yeah. BSS. Okay. Okay, but we still don't know what the difference between STSIM and LCSIM is. What's the difference? Okay, NSTSIM, NLCSIM. Yeah, hold on. LCOM symbol, static symbol. Well, that's not helpful. BSS segment variable with internal linkage. Data segment variable with internal linkage. Okay, well, it's not true. We have seen, wait, we have seen it. So STSIM is in a BSS segment. So whatever that just said there, data segment. Well, BSS is a data segment, right? Yeah. Okay, so the symbol 22. 22 and 7. 22 and 7. 22. SC sim 22. 13. What is 13? Man. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Data. Okay. Data is probably some custom data like structs, for example. No. Da, da, da. Yeah. Thirteen. 7, 22. Okay, but this one, this LC sim seems to be always 22. Right? Okay, how about we conditions? Symbol dot number of sections is not 22. Condition is not 7 and is not 13 and is not 22. Let's see. What else do we get? 11. 11 is const 1. Okay, then we know it is a const. Const 1. It's probably also in the name. Ah, no, it's maybe no. $11. And what else? 20. 20. 20. Const 2, I guess. This was 22, right? 20. Close. Okay. What else? 4. 4. 1, 2, C string. Okay, that makes sense. Where are we? Man. Condition. For what happened? Okay. Okay. And I guess this one here is always a no section, right? This never has a section. Yeah, 0. 0. I wonder if this description is some ID. An ID that you can use to look up the symbol. Maybe. Maybe. Could be, yeah. That would be my best guess, yeah. So we put a breakpoint here. 74. So this also has a number. To me it looks like it's some sort of ID. Yeah, maybe. Which would be good, because then we could make an ID lookup map instead of an address lookup map, since the G symbol doesn't have an address, but maybe we can look it up by ID. Yeah. Yeah. Maybe. We'll have to figure out. Okay, so I still don't understand the difference between this and this. Because this one, well, we can say that this one only concerns the BSS segment, the uninitialized one, but the STSIM also does. So I don't know. I don't know. BSS. Let's do some search here. What is the LCSIM difference? It's a bit small, isn't it? The step for the function is useless. Well, I don't like to read that. NSTSIM means the data section, and fun means the text section, and LCSIM means the BSS section. Well, that's not true. That's not true. Sorry, bro. That's not true. No init. Maybe. Aha. In XC of files, the step type need not indicate the section. CSTSIM can be used for all statics. Also, each static variable is enclosed in a static block. Maybe maybe it doesn't tell us anything. Ah, okay. Statically allocated symbol whose scope is local to a function. What is this here? Oh. The address is absolute. The address is absolute. Oh. Maybe there's no difference between the STSIM and the LCSIM. Maybe we just look at the section and that's it. But we don't make any distinction here beyond that. I really don't know what to say. Yeah. Then we say it's uninitialized if it's in the... Yeah. What we can do in the types here, we can say static local. I mean, I find it weird that it's called local symbol. But then it would only refer to being uninitialized. How does that make sense? Just because it's uninitialized doesn't mean it's a local symbol, no? I don't get it. Like, what is the thinking here? Data segment file scope variable. BSS segment file scope variable. Well, data segment file scope variable. Well, it's not true. Maybe it's true for some compilers. Yeah. Let's see if we can find some more info on this. Initialize static variables. stsim. Uninitialized lcsim. Well. File scope, procedure scope. Aha. File scope, procedure scope. Huh. I like this. I like this terminology. Let's make it a bit larger so you can see it. So what you can say here is S equals file scope V procedure scope. That's a better terminology. I like that. Okay, we have figured that out as well. Yes. Okay. Yeah. Uninitiate static variables. Yeah. Huh. Well, I guess what we could do is here what we can do is assert symbol dot section number of sections to fixed section. Oh my gosh. To fixed section. Oh, that's so retarded. To fixed section equals BSS, right? Expected uninitialized. Okay. Then static. Okay, then how about we call this static initialized and this static uninitialized. Global static initialized, static uninitialized. Yeah, but then we create a function bool is initialized, and we return section is not let's say has initializer value. Has initializer value. Section is not BSS, right? Okay, so this one doesn't tell us all that much here. Well, it tells us if it's global. So we can say bool is global, but we would also know that from address. I think we don't need type. Strictly speaking, we don't need type, I think. So what we can do here is this, we can do assert symbol dot name, symbol dot value equals 0, right? And here we expect not 0, and here also not 0, right? And then what we can say here is global. Is global const return address not 0. And that actually makes this information here, mtype, totally obsolete, but maybe we just keep it for now anyway. Let's make a comment here, obsolete information. Yeah. Okay, let's remove this and this. Let's run this and see if any of these breakpoints hit. Uninitialized, uninitialized, there we go. Okay, then here we call this static initialized, static uninitialized, okay. Okay, that has passed. No assert was hit, so our expectations are correct. Okay, I think we have a better understanding now. We know that we can totally ignore this type. Yeah, we don't care about this. We also don't need to care about the S and the V. We don't care about the G. We don't care about anything, because the information is in the section and in the address. That's it. And in the function index that we have here. Yeah. And in the symbol name, you would also know that's in a function. Yeah. Okay, cool. Okay, so we have a little bit of an idea. Yeah. Yeah. And then what we can also say, so hold on, the types were, right, consts, where are we? So we looked at C string, right? C string, literal, const 1, const 2, right? 11, data, yeah. Is const. Okay, let's go here. So the ones we have seen were those guys. Let's copy this here very quick. So number 4 was a C string. Let's write this down. So the C string. Number 7 was this one here. Number 11 was this one. Yeah. Number 13 was the data. Number 20 was another const. And 22 was a BSS. Okay. Then how about we say we go here and we say where's the variable? Huh? Yeah. So is global, and we say has initialized the value. Is C string. Okay. Is C string is literal 4. Okay. Then is const or section equals const 2. Okay. And then we make another is data. And that's it. It's not much here. C string, literal 4, const, and some data. Yeah. I'm surprised that there's no literal 8 statics. Okay. Okay, good. Then we have some intel here. What it is. Yeah. Good. Anything else for this session? Let's see what compiles. Yeah. Good. Then I think we're done here. That was 1 hour 30 minutes session. We learned a little bit about the variables and we tested, added a bunch of asserts. We consolidated the functions into one. It's looking good so far. I like this. This looks robust. And so next we can continue here and try to get all the information. And we are still curious about the description, what the number means. We haven't confirmed it, but to me it looks like it's an ID. ID of the symbol, maybe. Yeah, so we need to explore that a little bit. Yeah. Good. Then, yeah, I hope you enjoyed. I wish you a great day or night. Until next time, goodbye.